students, welcome to physics class. In this video, we are going to discuss about binary stars. What is binary stars? Two stars bound to each other by the gravitational force and orbiting around their common center of mass are called binary stars. Now, I will explain once again with neat diagram. Now take a circle, it is the center of mass. Take a tangent, here it is S2, take another tangent towards right side, it is S1. That means two stars, this is one star, this is another star. Two stars bound to each other by the gravitational force, and these two are having the gravitational force and orbiting around their common center of mass are called binary stars. Now take another diagram. Take here, consider one point, another point. One point, another point. One point, another point. Here S2 is in this direction and S1 is in forward direction. This is a helical path. Two stars bounded to each other by the gravitational force and orbiting around their common center of mass are called binary stars. Now I would like to explain and elaborate point by point. Now see, first definition. Two stars bound to each other by the gravitational force and orbiting around their common center of mass are called binary stars. Once again I am repeating. Two stars bound to each other by the gravitational force and orbiting around their common center of mass are called binary stars. Now, binary stars binary stars S1 and S2 of equal mass moving in a circular orbit around their common center of mass, which is at rest. When no external force acts on the system, the center of mass of the center of mass of the double star moves like a free particle. The orbits of the two stars are slightly complicated, or we can call as helical path. But these are just a combination of two motions. in which point number 1, the uniform motion of the uniform motion of the center of mass in a straight line and point number 2, the circular orbits the circular orbits of the two stars around their center of mass, Now the two stars, point number 3. The two stars always remain on the opposite side of the center of mass. Please stop. Now we are going to discuss about diatomic molecule. Now take a system of diatomic molecule like as O2. Consider O2. Here take how it will be associated. It is or then where is the center of mass? The center of mass is, now take the two molecules here. Here, this is the center of mass. That means once we can discuss about the diatomic molecule, the diatomic molecule will be connected like this. This is at the center. This is a center of mass. Now, I would like to explain point by point about diatomic molecule. Here, asymmetric diatomic molecule A symmetric diatomic molecule like O2 is also an example of binary system. Once again I am repeating, a symmetric diatomic molecule like O2 is also an example of binary system. The internal binding force between the two oxygen atoms is due to the chemical bond which can be recreated, which can be regarded as a spring. When there is no external force, when there is no external force, the center of mass of the molecules move with molecules move with molecules moves with uniform velocity in a straight line. Once again, when there is no external force, the center of mass of the molecules moves with uniform velocity in a straight line. We already discussed in the diagram. The molecules can also have vibrational and rotational motion. Vibrational and rotational motions. Again due to the internal forces. Even then, the center of mass moves like a free particle. Once again, I am repeating these 2 points. The molecules can also have vibration and rotational motion. Again, due to the internal forces. Even then, the center of mass moves like a free particle. Suppose, if we can take radium Ra means radium take, this is its motion. Suppose here is helium, it is called helium like this, helium. This is helium. Now take, this is Rn, radon. Rn is radon. Now where is the center of mass? The center of mass is in this direction. Consider it is center of mass. Now how we will explain? We will explain by theory, by point by point. Now go for discussion. Let us consider the radioactive decay of a moving unstable particle a moving unstable particle what is that one? Radium. Now the radium nucleus disintegrate and becomes as helium and radon. Now whenever it will be disintegrate, the center of mass is along this initial momentum of direction, that is in this direction. The radium nucleus disintegrate disintegrates into a nucleus of radon and an alpha particle and an alpha particle. The total linear momentum of the system is the same before and after decay. The radon nucleus and the alpha particle move in a different direction. But their center of mass moves along the same path. This is about diatomic molecule. If same type of the molecule, it will be move vibration as well as rotation. If it is a particle which is disintegrate, then the initial path only the center of mass will be. So I hope you understood about diatomic molecule of center of mass. My dear students, thank you very much for watching this video.